Ingo Philipp is Director of Product Management at UiPath. His responsibilities range from product strategy, product development, and product marketing to test management, test conception, test design, and test automation. Before that, he worked as a theoretical astrophysicist in the field of high-energy particle physics and computational fluid dynamics. He holds a Master of Science degree. During his talk, he will look into AI and software testing and some concerns that come with it, like where AI can deliver the greatest impact. Will AI take over software testing soon? What are the next steps testers have to take? Please welcome Ingo on stage.
Thank you so much. Thank you so much for joining this session, or I should rather say for still being here. You know, might think, oh no, right? Yet another talk about AI and software testing. But no worries, guys. So I will take a slightly different angle on that subject than Ron did in his talk. So, as you've just heard, I'm Ingo, and I think we need to get it right, Ron, because today I'm obviously buzzword Ingo, right? Because I will play a lot of buzzword bingo with you in the next 35, 40 minutes or so. Because my talk will solely focus on AI. So I've been around in software testing for about 10 years or so. And especially in the last 5 years, a pattern emerged. A pattern emerged in all the discussions I've had about software testing. And in most of these discussions, AI was a major topic. It was an essential topic. And most of these discussions ended up with the question, will a bot steal your spot in software testing? Often after a couple of beers, to be honest. Now that's the simple reason why I want to tackle this question in that session. Now for those of you who need or want to leave in about 1 minute or so, here is my short answer to this question. And it comes in two parts. I believe that in the near future, that means in the next 10 to 20 years, it's highly unlikely that machines will become our overlords in software testing and so completely remove the human element from testing. But in the far future, whatever happens next, I think it's quite likely that machines will just take it over with respect to almost any intellectual human task out there. Now, most of my talk will focus on the near future of AI in software testing, but nevertheless, I would like to give you at least a brief explanation why I'm making such a bold statement about the distant future of AI. And here my reasoning is based on 3 simple assumptions. Assumption number 1, I believe that intelligence is just an emergent phenomenon. So I believe that intelligence is just a byproduct of especially complex information processing. And it might be the case that we, as human beings, in our brains follow a different kind of computational logic to process that information than, for example, classical Turing-type machines or even quantum computers. But nevertheless, I believe that the computation that is going on in our brains is what eventually gives rise to a phenomenon which we call intelligence. So this means, in short, I don't see any necessity for any metaphysical things such as a soul or a god that allows us to be intelligent. That's assumption number 1. Assumption number 2 is, I believe that we will continue to improve our technology, to improve it with respect to its computational power, with respect to its memory capacity, or the data we will have available to feed those AI systems. That's assumption number 2. Assumption number 3 is, I'm strongly convinced that we are by far not at the peak of intelligence. So to me, human intelligence is just a minuscule dot on a minuscule dot on a minuscule dot in the vast space of all possible intelligences. Now guys, if you agree to those 3 assumptions, I think you will have a hard time finding anything that will fundamentally block us from creating machines that will far surpass the intelligence of the brightest human minds. And I want to make it crystal clear. All I've just said is what I believe. So I can't give you any factual evidence for that, nor I can give you any solid reasons for that. And that is what Richard Dawkins calls faith. So according to him, faith is belief without evidence and reason. Now the problem here is that this is also the definition of delusion. And this means that all I've just said, I might be completely wrong with it. And I might be completely wrong with what I will say in this talk. So what does it mean for you? Well, it simply means everything you hear in this talk is an opinion. It's my opinion, it's not a fact. And everything you see, that's my perspective. That's not the truth. So guys, please keep asking, keep doubting, because then, according to Richard Feynman, it gets a little harder to believe. Now, having said that, and having probably lost 50% of the people right now, let's dive into the near future of AI in software testing. And let me tackle that in 3 parts. In part A, I would like to explore the hype that is around and about AI in general, to figure out why we are even asking this question, will a bot steal your spot in software testing? In part B, I would like to explore the concept of intelligence, to enable you to understand my answer to this question. And in part C, I would like to explore testing itself to finally give you my answer. So that's the master plan. I hope it works for you guys. So let's dive into that. And let me start with this person here. His name is Andrew Ng, and he's probably, at that very moment, the most famous AI researcher out there. So he's a professor at the Stanford University and the co-founder of Google Brain. And he once said, just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of an industry that I don't think AI will transform in the next several years. And you know what? I absolutely agree with him. Because especially the recent achievements of artificial intelligence, they are stunning. They are remarkable, and often they are just overwhelmingly impressive. And when you see these AI systems in action, you probably look like this, or like that, or like this. Because you say, well, I mean, when AI is already able to achieve that at the very moment, AI will probably be able to achieve anything and everything beyond that, right? Or maybe you will look like this once you realize the potential impact those AI systems can have on your work life especially. But if you dive a little bit deeper into the technical specifics of these AI systems, of these algorithms, you will probably look like this. Because you will start realizing that those intelligent computer systems, they aren't made of magic, okay? They are made of pure logic. And that's the good news out there. Now, nevertheless, it's just a fact that nothing, really nothing, has moved as fast as AI is moving right now in the enterprise. Right? And the press is full of statements such as AI is the new paradigm, the next digital frontier, the next disruptive force in technology, at least for the next decade. Or some people even claim it is the new black or the new electricity out there. And believe it or not, but some people even go beyond that. People like Ray Kurzweil. Now, Ray Kurzweil is a futurist, an author, and he's now currently employed at Google as a director of engineering there. And in 2005, he wrote an amazing book, highly recommended. It's called The Singularity is Near. And the ideas he's sharing in this book were already developed in the 80s, 90s, in his previous books. And in all these books and all the papers that followed from these books, he makes really bold statements about the far future of AI. So he, for example, says, we will be able to fully back up our brains. We will be able to think in the cloud, or we are going to put gateways to the cloud in our brains, or by the late 2030s, human thought will be predominantly non-biological. Or, and now it comes, guys, we will be uploading our minds to computers and so become emotional by 2045. So please mark that year in calendar, because according to Raymond Kurzweil, that is the point in time when we reach the so-called singularity. It's often known as the AI takeover. And that's a point in time where we will have machines that are millions, billions, or even trillions times more intelligent than human beings. Now, the reasoning of Ray Kurzweil is based on what he calls the law of accelerated returns. And in really rough terms, this is based on Moore's law. And I think we all know Moore's law, right? It just states that the number of transistors in a dense integrated circuit doubles every 2 years. Now, Kurzweil says that this empirical law doesn't hold true just for transistors, it holds true for technology in general. So he's saying that technology becomes more powerful at an accelerated rate. In simple terms, this means that technological advance is not linear, it is exponential. And then another guy from the University of Wellington, Nick Ager, came around and asked, well, but what does it take to get there, right? And again, he split it up into two parts. He said, the first thing we need to do is we need to master the software of human thought. That means we need to be able to simulate the human thought process in its entirety. And then we just need to get machines that have at least the computational power and the memory capacity of the human brains. And you know what? It's quite surprising that most people truly believe that this is just around the corner, especially people in the software testing business. Because I hear so many people saying that we're just a baby step away, right, from eliminating the need of human thinking in software testing. Because, you know, the software testing are such an amazingly stupid species, according to these guys. Now, I do not agree with that. And therefore, I don't want to sell you AI like this. I don't want to sell you AI in software testing in the same way miracle weight loss programs or anti-aging face creams are being sold to you. I really want to keep it on a serious level, guys. So to do that, let me talk about the concept of intelligence. And Robert Sternberg once said, there seem to be almost as many definitions of intelligence out there as the number of experts asked to define it. This simply means that there is no standard definition of intelligence out there. And so I searched for a definition of intelligence. And in my search, I came around this paper here. It's called A Collection of Definitions of Intelligence. And here two AI researchers, Shane Legg and Markus Hutter, collected over 70 definitions of intelligence from various fields, such as mathematics, physics, AI research, computer science in general, psychology, philosophy. And they also collected definitions of intelligence from various organizations, such as Google, Netflix, Facebook, and so on and so forth. And what these researchers were trying to do is they were trying to identify the core characteristics, the core attributes of intelligence from these definitions. And with those core attributes, they tried to compile a definition of intelligence. They called it universal intelligence. Now, when you read through those definitions in that paper, you will see that intelligence is often linked to phenomena like emotional thinking, critical thinking, logical thinking, like problem solving, communication, perception, modeling, planning, abstraction, generalization, learning, imagination, creativity, memory, experience, judgment, understanding, knowledge, and the ability, for example, to manipulate environments, the ability to adapt to ever-changing environments, or the ability to set strategic goals. And you know, when I realized that, I immediately thought that intelligence truly is a suitcase term. So it's an enormous suitcase that contains all sorts of different phenomena we can't really explain. So it's like that you have a suitcase, you put all those phenomena into it, you close it, and then you call it intelligence. That is what it is for me. Now anyway, one definition I really liked in that paper was this one by Edwin Boring. And he said intelligence is what is measured by intelligence test. So that makes sense, right? So what are these tests out there? And just a 30-minute research led me to those tests here. Ron just touched on the Turing test, right, with the Google Assistant. But there's also a reverse version of the Turing test out there. And that is where you have an AI, and that AI, for whatever reasons, creates the necessity to perform a Turing test on you. Now, this is now regarded as the true Turing test out there. But the one test I really liked most is the one here at the bottom. It's the so-called Ikea challenge. And here you have a robot, you put some general purpose AI into that robot, and then you ask that robot to put something together from Ikea, some furniture, a chair or a table, for example. And quite surprisingly, I wasn't able to find any case study that truly shows that an AI can do that. And some people say that says more about Ikea than it says about the field of AI research. Anyway, the definition those two researchers came up with in that paper was this one. They concluded that intelligence measures an agent's ability to achieve goals in a wide range of environments. And I know it's still fuzzy, right? It's still abstract. But it, I think, gives a good starting point. And After that, another well-known AI researcher, Chris Bishop, came along and basically said, oh guys, when this is intelligence, then artificial intelligence is definitely anything machines can't yet do, right? And the reason, I guess, why he was saying that was that these guys in the paper were talking about the most general form of intelligence. And so they were talking about the most general form of artificial intelligence, which is now known as artificial general intelligence, or AGI, sometimes also referred as pure, strong, full, or general purpose AI. And in rough terms, this is a machine or a computer system in general that has the ability to apply intelligence, in the way we defined it before, to any problem. Now, this does not mean that these computer systems can solve all problems. It just means that they can apply intelligence to those problems. Now, the question that comes up then is, well, will we as humans ever be able to create that general form of artificial intelligence? Well, Martin Kraft has a take on this, and he says, no, because humans aren't generally intelligent. Man, that's obviously a fun statement, right? The bottom line here is we don't have that form of artificial intelligence at that moment, okay? So my conclusion is that the field of AGI, artificial general intelligence, is just the study of what we could do with machines we don't have at the moment. So what we have at the very moment is a very narrow form of AI. And so we call it artificial narrow intelligence, or ANI. And that is where you have a machine or a computer system that has the ability to apply intelligence to a very specific problem, or to problems in a very specific domain. And we all know those amazing examples out there, right? DeepMind, for example, with AlphaGo in 2017, that just made a dent in the universe of AI research. But just outperforming the best human Go players on that planet. Or we all know those amazing ANIs all about recognizing faces. Facebook recognizes an example here. Or all these amazing cognitive services from Microsoft on their Azure platform, for example, where you can, for example, interpret your images. Or we have seen ANIs that completely outperform humans in playing Jeopardies. Or we've seen ANIs that outperform humans in detecting diseases. IBM Healthcare, for example, is here the keyword. Or one thing that should never be missed in the talk about AI, for example, are self-driving cars, right? And this list could go on and on and on forever. So artificial narrow intelligence is everywhere. It's in every single industry. It's in healthcare, it's in agriculture, it's in energy, it's in telecommunication, it's in banking, it's in insurance, and so on and so forth. Now, don't get me wrong, I mean, those achievements are amazing, and especially self-driving cars, they're a great leap forward, right? And they probably will become a commodity in the next 5 years, especially in the US, California, or in China, right? But the thing here is, they can only do one thing. So a self-driving car cannot play chess, or it cannot interpret an image, or it cannot translate something. It's not able to abstract, for example, language or voice, for example. But the interesting thing here is that an ANI, an artificial narrow intelligence, can give rise to an artificial general intelligence. And one advocate of this idea is this person here. His name is Ben Grötzl. And he is, as far as I can see, the leading scientist out there in the field of AGI. And even though it doesn't really look like that, right? So he's the co-founder of Singularitynet and OpenCog, and we'll get to that in a second. Now, if you don't know Ben, I guess you know her, right? Sophia from Hanson Robotics. Now, Ben was the chief scientist at Hanson Robotics, and he headed the engineering team that created Sophia, for example. And Ben is an advocate of the idea that you can create an artificial general intelligence from a network of ANIs. And his ideas are fully based on the ideas Marvin Minsky already started to develop in the 70s and the 80s. And in the 80s, he wrote a fantastic book. It's called The Society of Minds. And in that book, he lays out the idea how to achieve that. And that is the idea Ben Grötzl tries to implement with what he calls Singularitynet. Now, Singularitynet is a decentralized AI network. He calls it a blockchain-based AI marketplace or platform. It's fully based on the Ethereum platform. And the cool thing about this is it's open for everyone. So everyone can contribute to that platform. Everyone can create, share, and monetize AI services there. And they just released the first beta version this year in March. And now I think they're at version 3 with Singularitynet. So what's the key idea behind that platform, behind Singularitynet? So now imagine that this rectangle here represents that platform, that blockchain-based AI platform. So what you can do as an individual or as an organization, you can put a request into that platform. For example, you want to have some problem solved. And in that platform, you then find a bunch of different artificial narrow intelligence systems. And each of those systems is focused on one particular task, one of which might be focused on image recognition. Another one might be on sales prediction, weather forecasting. Another one might be focused on playing Go, playing chess. Another one might be focused on interpreting images, and so on and so forth. So when you put that request into that platform, those AIs are able to communicate with each other. When they consume that request, they are able to cooperate with each other. And they're also able to offload work to each other. And they're also able to rate themselves each other. And the hope in AGI research is that out of these interactions between those ANIs, intelligence in its most general form emerges just like that. Now, Singularitynet was the first of these platforms out there. And just after Singularitynet was released, a bunch of other blockchain-based AI platforms popped out of nature. And what do you do in that case? Well, you create an alliance, right? That alliance is the DAIA, it's the Decentralized AI Alliance. So it's a decentralized alliance of decentralized AIs. And you can think of it like an ecosystem of ecosystems, or a network of networks. Like we as a human being, we are nothing more than just a network of networks. Or our society is nothing more than just a network of networks. And again, the hope of AGI research is that out of these interactions between these individual parts of that network, intelligence emerges. Now this is, as far as I can see, the cutting edge of AGI research at the moment. So now let's see what this all means for software testing. And let's first make sure that we all speak the same language here. Now imagine that this rectangle here represents your software product. And imagine that this represents the entire functional and non-functional spectrum of your software product. And it also represents all the possible environments your software product could be situated in. And it also represents all the people that might use your software. Try to imagine that. So that's all there is, and that's all you could possibly know about your software. Then the green rectangle is what you currently know about your software. And this rectangle is apparently smaller than the previous one, because you will never be able to always know everything down to the very last detail about your software product. The red rectangle is what you repeatedly check, for example, through automated test case execution in your software. And again, this rectangle is smaller than the previous one, because you will never be able to check everything you know at any time in your software. Now the question is, well, would it even make sense to go for that? Would it even make sense to strive to automate, to codify everything you know at any time? Well, most people say, yes, that's the ultimate goal, right? We need to automate testing. But I'm saying no. And the reason for this is simple. If you solely aim to codify everything you know at any time, the question is, how on earth would you then be able to create new knowledge about your system? And you have to create new knowledge about your system. Why? Because your system, your software is constantly growing. We're adding functionality, we're changing our software, and so you constantly need to increase the knowledge about your software to detect problems that are far, far outside your checking regime. Now this is what testing means to me. Testing is all about closing this knowledge gap. It's all about closing the gap between what we know and what we don't know about our software. So to me, the goal of testing is collecting quality-related information rather than doing automation. And Ron also shared his ideas on that. So to me, testing is, and always has been, and probably always will be, a search for information. And Jerry Weinberg once explained it to me like this. He said, Ingo, think of what a test actually is. And he said a test is a question you ask your software. And the point of running that test, of asking that question, is to gain information. And the reason why we want to collect that quality-related information, for example, the risks, the problems that might happen in our software, is simple. With that information, we just want to enable other people, like product owners, product managers, developers, to make better decisions. Decisions such as shipping decisions or fixing decisions. Now, this picture already suggests how I see testing. So to me, something is thoroughly tested when it has been checked by efficient automated test case execution based on a solid test case design, of course, and when it has been explored by the richness of intellect of human beings. So to me, the coin of testing has two sides. The first one is all about checking. And the main reason why we do that, as Ron already explained, here we only have the goal to monitor our known risks. So here we just want to confirm what we already know. We confirm our existing beliefs. The reason why we want to explore, investigate, and experiment with our software is we want to analyze potential risks. We want to find new information, quality-related information about our software. Now let's dive a little bit deeper into that. When we check something in our software, Michael Bolton says, then we evaluate our software by applying algorithmic decision rules to specific observations of a product. Now, usually nobody gets that, right? In simple terms, this means that here you operate your software in a mechanistic way. And you do that to answer a very simple question. And the question is, does this assertion pass or fail? And this question always has a binary answer. It's either yes or no, it's on or off, it's 0 or 1. And so this means this question is machine decidable. And this means that you can automate the process of finding an answer to this question. And you know what? It should be automated. Because I don't want to do what a machine does. I want to learn about my product as a human tester. I want to do that through exploration, experimentation, and investigations, and many other human capabilities. And the reason why I want to do that is I want to tackle a much bigger question. And that question is there a problem here? And this question usually does not have a binary answer, right? So this means everything you see on the left-hand side from that black and white perspective, I have to say. That's really easy to automate to some extent. Everything you see, what happens on the right-hand side, that's the tough thing to automate. Now let's dive one level deeper. And let's ask ourselves the question, well, what needs to happen before we are able to even perform a check? For example, in an automated way, by, for example, executing an automated test case. And then let's ask the question, what needs to happen after we perform the check? Now, before you are even able to perform a check, you need to learn about your software, right? And you do that by studying your software. You do that by reading specifications, design documents, architecture documents. You do that by talking to your developer friends, to your product managers, to your product owners, to people from operations, for example. Now, you collect knowledge about your software. And this at least creates the illusion that you understand your software, right? But once you understand at least parts of your software, you are then able to recognize, identify, and prioritize risks that might occur in your software, problems that might happen in your software. And then you translate that risk into a test idea. And then you express the test idea into a binary question, into a question that can be answered by a machine, into a yes or no question. And then you turn that question into code. And then you need to find a trigger to launch that check, and then you encode the trigger to automate the check. And then you perform the check. You automate your test case, and you execute it. Now, after you did that, you must read the bits, right? You must aggregate those results. You design, for example, reports. And you encode those reports because you don't want to design them over and over and over again in a manual way. And then you need to observe those reports. And the reason why you need to observe those reports is you need to judge the significance. And you need to determine the meaning of those findings. And then you respond to whatever you have found. And through that you learn something new and the whole story starts again. The bottom line here is that checking, and especially automated checking, some call it test automation or test case automation, is just, again, a minuscule dot on a minuscule dot in the space of testing. Now let's dive one level deeper and ask myself, well, what are all these activities I perform when I'm doing testing? So I've tried to find a flat list of activities that clearly show what I'm doing when I'm challenging my software to evaluate my software. So here's my substitution of testing. When I'm doing that, I'm applying a lot of human capabilities, such as learning, exploration, experimentation, modeling, studying, drawing inferences, I'm questioning facts, I'm assessing risks, I'm prioritizing those risks. I'm applying a lot of judgment, critical thinking, emotional thinking, logical thinking. I'm developing a hell of a lot of code, right, to perform some automation. I'm advocating bugs. I'm managing a hell of a lot tacit knowledge that is involved in the whole process. And this list could go on and on and on forever. So I want to come back to the question that I raised at the beginning, will a bot steal your spot in software testing? And that is a question you can answer for yourself. Just create that list of activities you perform when you do testing. And then for each item on that list, decide whether this can be automated in its entirety or not by some tools out there. And if you don't know what tools to look for, here's a short list. Ron also has shared some tools. And these tools flag themselves as AI-based testing tools. And especially their marketing teams, right, they make really bold statements. Like, we automate every single step of the testing lifecycle. We automate test design, test planning, and test execution. We provide autonomous testing, right? Now, don't get me wrong. I don't want to talk negatively about these guys. I highly value what these guys are doing because they are the first ones who are trying to bring AI and machine learning into our disciplines. So we should rather value that. We should blame their marketing teams. That is my assumption. So the homework I want you to do is create that list of activities you perform during testing. And then parallel to evaluating those tools, decide for every single item on this list if this can be automated at that very moment or not. And then you have an answer to the question whether a bot already steals your spot in software testing. I also did that exercise. And my conclusion is obvious, right? To me, there is no such thing as automated testing yet, just as there is no automated programming yet or automated product management yet, right? So I still like to talk about automation in testing, like Richard Bradshaw says. I do not like, for that simple reason, to talk about automated testing. Now, in testing is inherently linked to quality. And the reason is simple. There is no chance to talk about testing without talking about quality. So what does it really mean? I looked it up in a dictionary, and the dictionary says quality just measures the excellence of something. And that is quite an okay definition, I would say, because if you say, well, this is excellent, you actually say this is of high quality. But it doesn't really matter. The question here is, who measures this degree of excellence? And it's always measured by someone. It's measured by a human being. And that was one of those reasons why Jerry Weinberg said quality is value to some person who matters at some time. Now, the person he's referring to are our stakeholders, our internal and external stakeholders, our customers, for example. And those stakeholders might come and might go because your business is changing and the market changes, right? Now, how do we create value, attain value for these people? Well, we do that by helping them to solve their problems, by helping them to satisfy their needs or to satisfy their goals, to allow them to achieve their goals, for example. So my simple rule of thumb, I always try to keep that in my mind as a product manager, that the only reason why we build our software is to provide a solution to someone's problem out there. And if the problem isn't solved, the software simply doesn't work. Now, all this means that quality is inherently subjective. And this means that different stakeholders will perceive the same product as having different levels of quality. Now, think of it like this. Say, well, what might be usable for you, for example, in some software, might not be usable for me. So we have a different perception of what quality means. And this means to us testers, we must look for different things for different stakeholders. And this says a lot about what a bug is. Now, to me, a bug in its most general form is just anything that might threaten the value of our software products. And James Buck once said, a bug is something that bugs somebody. Now, that's obviously a fun statement, but there's also deep meaning related to that. Because this says that a bug is not necessarily within our software products. It is more about the relationship a person has with our software product. And exploring that relationship between the stakeholder and your software, that's a testing activity. Because to me, testing, again, just means challenging software to evaluate software. And evaluating software just means being able to make value judgments about software. And this just means being able to assess whether something is good or bad for a specific person in a specific context. And this just means that we don't just have to verify our software in terms of figuring out whether our software meets whatever is written in the specification. In ISTQB terms, this also means we need to validate our software. We need to figure out whether our software meets the end user's needs. And that is, for example, the type of testing I'm doing as a product manager every single day. Now, how do I do that? I'm talking to our stakeholders. I'm having conversations with our stakeholders. And the only reason why I want to do that is to evaluate our software. So that means I'm studying our stakeholders. And this means I'm studying humans. And because of the fact that social science is the study of humans, testing is a social science too. Now, what does this imply? This implies when we want to truly automate testing from that holistic point of view, we need to automate these aspects of social science too. And this turns out to be a damn hard thing to do. And one reason why this is such a hard thing to do lies in the, let's say, the peculiar dignity of tacit knowledge. And Harry Collins once wrote an amazing book about it. It's called Tacit and Explicit Knowledge. Now, tacit knowledge is not some magical form of knowledge. It is knowledge that is just hard to transfer from one person to another. For example, by writing it down or by verbalizing it. So tacit knowledge is knowledge that is based on our hunches, on our intuition. It is based on our experiences and all the emotions and feelings that go along with those experiences. And the interesting fact here is that most of the knowledge in your heads is tacit knowledge. So it's knowledge that's just hard to share because you cannot really formally express it. But on a daily basis, by talking to people, by writing articles, we make the tacit knowledge, sometimes also called implicit knowledge, especially in neuroscience, we make it explicit in terms of having facts, figures, rules, algorithmic procedures. We write articles, we write books, we put something into data. That is how we make tacit knowledge explicit. And I want to be honest with you, some aspects of tacit knowledge can already be managed by machines. Now, one classical example of this is facial recognition. So for those of you who know me, they know that this is my face, okay? So this face belongs to Ingo. And you can recognize my face among millions or even billions of people. That's an easy task for you, right? But you cannot write down algorithmic rules or procedures that define why this face is my face. That's a damn hard thing to do. And sometimes I think it's just impossible to do for us humans. But you know what? Machines can do that, right? Especially convolutional neural networks. They just do it. And they do it with a much higher accuracy, efficiency, than we as humans can do that. But there are also aspects of tacit knowledge machines cannot model yet. And this is, for example, the task of figuring out what the goals, the needs, the problems, the wants, the desires of our stakeholders are, and interpreting all of these things and setting actions on that. So this is currently debated a lot, especially in cognitive sciences, whether machines will ever be able to model, manage tacit knowledge in its entirety. And the majority of cognitive scientists, as far as I can see it, claims that this might require a much richer model of cognition and knowledge representations in our AI systems to be able to do that. But again, when we want to automate testing in its entirety, we need to be able to manage tested knowledge in its entirety. So that's the bottom line. Now, having said all this, let me briefly sum it up. And let me sum it up with my 4 main takeaways. Number 1, Jerry Weinberg. I think he once nailed it. He said, the number 1 testing tools is not the computer, it is still the human brain. And I think that still holds true and will also hold true at least for the next 2 decades. So the most important intelligence at that very moment is not artificial. And so my advice to you is, please do not hype yourself up too much into thinking that AI can achieve anything and everything beyond that. So do not expect artificial intelligence to solve all your problems soon, guys. Do something about natural stupidity in testing now. And please, please don't think like that person in the picture, right? Until, of course, some general purpose artificial intelligence like Skynet comes around and just takes over the world of software testing, right? But again, I do not see that this will happen anytime soon. So instead of thinking about AI-based testing, I would like you to think about AI-assisted testing. Because AI is just another technology at that moment, another tool that amplifies, accelerates, intensifies, simplifies, and enhances what we as humans do in testing. It doesn't replace the human element from testing. And guys, if all this will once happen, if a bot will once steal your spot in software testing, then I am convinced that this bot will steal everyone's spot everywhere too. And the simple reason for this is, testing to me is a thinking process. It is something that happens in our heads. It is not something that happens in our tools. So if you want to change the way you test right now, please don't put all your money on AI right now. Rather change the way you think, guys. Thank you so much. Thank you.
Thanks a lot, Ingo. And well, you can answer your questions in the app. And we already have the first question here. So it's about Isaac Asimov's robot laws. What do you think of it?
Let me go through the question.
Well, please read it out. So.
Let me. So the second question is yes, of course. I already shared the presentation. The first question, I'm more concerned with what values we kick off the first general artificial intelligence. And the reason why I'm so worried about this is because our value set also changes over time. I mean, just go 50 years back, okay? 50 years back, gay people, right, they were almost killed. Black people, I mean, they were not accepted by society. This was the state of art of our values just 50 years ago. And I don't even want to know how we see our values right now in 50 years, for example. So I don't want to kick off a general intelligence, artificial general intelligence, with this poor set of values. So I'm worried about this. I'm also worried about who designs these laws. I'm worried about that there is a company out there, maybe Google, let it be Facebook, that really creates first such an artificial general intelligence. And therefore I like so much all those open source activities, such as Singularitynet, right? To take away that power from these companies and so from these nations. So I hope that somehow gives some answer to this question. Any other questions out there?
Well, I do see new questions appearing. Does anyone have a question you want to ask right now? I'll bring the mic to you. No? Probably you have seen, always Ron has a question.
Hey, thanks Ingo for the talk, that was really amazing. Your question is, will a bot steal my spot? And I'm saying, well, hopefully, because all these stupid things, you also distinguish between testing and checking. I think all those stupid checks that you can automate, that are boring, they should be done by a bot. How do you see that?
Absolutely, absolutely. And you know, I think this is one of, let's say it's the major reason why we now have the market of RPA. That's the market I'm in, right? Robotic process automation. Now, the only thing these tools in RPA are doing is they're automating those repetitive, dreary, uninteresting tasks that are consistent over time. The only reason why this market exists. And you cannot imagine how much repetitive work in an organization exists. We are blessed to be in the software development department, honestly, in organizations. If you look into IT, and especially if you look in the business department, the whole world changes a lot. So Ron, of course, I absolutely agree, right? So that is what I think what we will be able to achieve soon already with artificial narrow intelligence, right? But to set the stage for checks, I think we need to have some general form of intelligence out there that does it for us. Hope that answers your question.
Okay, well, thank you very much, Ingo. And give him a big hand.
Thank you so much. Enjoy your conference.